Hey everybody, my name is Calvin and welcome back to episode 4 of my Learn Python series. Today, we'll be covering loops in Python. What are loops? Loops are how you repeat code without having to copy and paste the same lines over and over. So, anytime you need to do something multiple times, go through some set of values, or keep running until some condition is met, you can use a loop. There are two core loop styles in Python that you'll see constantly as a beginner Pythoner: for loops and while loops. A for loop is used when you want to iterate over some sequence of values. A while loop is used when you want to keep looping as long as a condition stays true. Before we jump into the exercises, as always, the course repository will be linked in the description. I highly recommend watching the earlier episodes before this for the best learning experience. Let's jump into the exercises. Like before, we'll create a lesson 4 folder, and we'll keep all of our exercises in there. We'll create a file called for-1.py. In this file, I want to introduce us to range. Before we can use for loops comfortably, we need to understand the range function, because it's the most common beginner way to say repeat something a certain number of times. The range function is not a loop by itself. Rather, it's a value that represents some sequence of integers. You can think of it as a generator of numbers. The for loop is what actually will step through that sequence one number at a time and runs your indented block for each number. The most common form is range with a single parameter. In the range function here, the 5 is the stop parameter. In this default form, it always starts at 0, it always counts up by 1, and it always stops before the stop value. So range 5 would produce exactly 5 numbers: 0, 1, 2, 3, and 4. Notice how the stop parameter here, 5, that we passed in, was not printed. That's because range will always start at 0 and count up. We do not include the stop in here. The easiest way to understand that is to print the values as they come out of the range. In this loop that I'm about to write, the only job of the for loop is to take the next number and store it into the variable I, then run the print line. So we initiate I right here, and we'll print it. You can see 0, 1, 2, 3, 4. That's because for every iteration in this for loop, I increases by 1, like in range. We're simply just printing out the numbers that range produces. Now, we can also add another parameter into the range function. This time, we can pass in a start and a stop. So it'll look something like this, with 1 being the start and 5 being the stop. We can write the for loop for this again. The difference between this range function and this range function right up here is that we're going to start at 1 and increment until just before the 5. So in this case, we should expect something like 1, 2, 3, and 4. And we can run this to confirm. You can see that's exactly what we expect. Comment that out so you can see 1, 2, 3, and 4. Another cool thing that we can do with range right here is we can add a third parameter, which is step. The step is literally how much the number changes each time. As before, our default was 1. We incremented by 1. We can put in a step parameter of 1, and it'll look exactly the same as the ranges before. However, if we passed in a step parameter of 2, then we would skip by 2 instead. If the step is 3, you jump by 3 as well. So say we had 1 and a 5, and we passed in a 2 step parameter. Let's see how this works. What should we expect here? we should expect something that looks like 1 and 3. Notice how we still start at 1, we go up to 3, but we don't ever want to hit the stop condition. So since this step can't go up by 2 without violating the stop, we only print 1 and 3. We can run this and confirm. Now if I change this to a 6, we could expect something like 1, 3, and 5. The big takeaway here is that range is just a clean way to generate loop numbers. The for loop is what will use those numbers. Let's jump into actual for loops now. In a different file, we'll create our first for loop. Our first for loop will use a loop the way that beginners will actually use it, to repeat some action a fixed number of times. For example, this loop will print a statement 5 times. The loop variable exists here, but it's never used. We just use the fact that the loop runs once per value. Remember, in range, we have 0, 1, 2, 3, and 4, which repeats 5 times. Now, I would also increment by that number because it's corresponding with whatever range number is in here, but that doesn't matter for us, since all we're doing in the indentation is printing hello. So all we should expect is hello printed 5 times. Now, let's use the loop variable so the output changes for us each time. The loop variable is what holds the current value for the current iteration like usual. So we can have a slight iteration of what we did before for demonstration purposes. Say we wanted to have something like attempt, and we wanted to print I instead. We should see attempt 0, 1, 2, 3, and 4. Now, a beginner misunderstanding is that range will start at 0 instead of 1. If we wanted it to start at 1, we would just simply add a 1. So now we can have attempt 1, 2, 3, 4, and 5 for human readability. Another key thing to note is that the variable here can be anything. It doesn't need to be I. It can be number, and could be X, Y, Z, number, whatever you want to call it. Hopefully this gave you a glimpse into what exactly loops are capable of. Let's jump into our third exercise. In here, I want to create a running total pattern. This is one of the most important loop patterns you'll learn pretty early on. You initialize a variable before the loop, update it inside the loop, then use it after the loop. We're going to compute a running total. Total will start at 0 because 0 is the correct starting point for addition. Then each iteration of the loop will add the current number into the total. So say I wanted to do something like for I in range 5, and I had total is equal to total plus I. Now the total variable up here will increment by I every single time the loop is run. Now also notice that for each iteration, I will change according to the range values. What should we expect here? We should expect to see a 10 in the total print statement. Why? Because we're doing something like 0 plus 1 plus 2 plus 3 plus 4. 1 plus 2 is 3. 3 plus 3 is 6, and then 6 plus 4 is 10. We can run this, and we'll see that we do indeed get 10. Moving on to the next exercise. I want to cover a loop with simple conditionals. Now, we can combine the loops with the if, elif, else statements that we covered in the lecture before. This is where loops become especially powerful. You could apply the same decision logic repeatedly to many values. In this example, we're taking each number and categorizing it into a low, medium, and high. Say we had a for loop for I in range of 10. Now we can have something like if I is less than 3, then we want to print is low. And let's say we also wanted the number in here. If I is less than 7, then we can print I is a medium number. Else print I is a high number. Now we should see something like 0 is low, 1 is low, 2 is low, and so on. 0 is low, 1 is low, 2 is low, 3 is medium, 4 is medium. Since I increments by 1 each time the loop is run, we evaluate these statements every time. We can kind of look at it like a mini decision process that happens 10 times. For each I, Python checks the conditions in order. The first condition that's true is the branch that runs. Then it moves on to the next iteration. Moving on to the next concept, I want to cover break and continue. These are loop control tools. They change the flow of a loop while it is running. Break means stop the loop entirely, and the loop ends immediately, and then execution continues after the loop. Say, for example, we had for I in range of 10, but we had a conditional in here that said we wanted it to stop when I is equal to 5. Break. I'm going to print I. Now what would this print? It would print 0, 1, 2, 3, 4, and 5. Now once we reached I is equal to 5, it breaks out of this whole entire loop right here, and nothing else is printed. We can confirm this. I misspoke because the loop breaks out. Notice how the loop is broken before we ever print 5. So that's why it only goes up to 4. So really, this loop would produce 0, 1, 2, 3, and 4. Now, if we were to move the print statement up here, then my previous statement would have been correct. Now let's take a look at the continue. Continue means skip the rest of this iteration and go to the next iteration, and the loop does not end. It just skips what comes after continue for that one singular pass. So say, for example, we had pretty much the same example up here. Let's uncomment that. For I in range 10, say we were interested in replacing our break with a continue. We again print the numbers right here. Now, we never break out of the loop. We don't ever break out of the whole entire thing. Rather, we just skip that singular pass in this for loop. So what should we expect here? We should expect to see something like 0, 1, 2, 3, 4, right? And then we skip to 6, 7, 8, 9. And we can see that's exactly what we get. And now if we were to move our print statement up here though, this continue block would not even matter because we've already printed our 5 in that specific iteration. So now if we print it and then we evaluate the conditional equal to 5 and continue, there's nothing else after this block that actually matters. So we should just get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see that's true right here. So the order matters in Python. In the next file, I'd like for us to cover your first while loop. A while loop, as I mentioned, repeats as long as its condition stays true. The important difference from a for loop is that while loops don't automatically move on to the next value. You have to update the variables involved in the condition so the loop can eventually stop. Here we can use a counter, kind of like exactly what a for loop does behind the scenes. So we call this 0. And then we can do something like while count is less than 5. Oops, while counter is less than 5. We can print count, counter. And we can increment counter by 1. This would give us 0 through 4. The most important line here is this counter equals counter plus 1. That's what changes this condition up here over time. Each loop, counter increases, and eventually counter is no longer less than 5, so the loop ends. A beginner mistake would be to forgetting to update count. If you don't ever increment counter, then counter stays 0 forever and the while loop will run forever, creating what we call an infinite loop. Since we have a guard in place, that doesn't matter. 0, 1, 2, 3, and 4. Now, let's say we commented this line out. Now we would just see a whole sea of zeros. And that's what we call an infinite loop. In the next file, I'd like for us to cover looping over a list. A quick note, we're using a list here to show what looping looks like in real code, but we'll cover lists in the next episode, and we'll formally go over lists. For now, treat a list as multiple values stored together in order. Say we had a names list right here. We can have John, Ava, Steve, and say my name. We can do something like for name in the list of names that we just defined. And we can print each name. Now, names here has basically replaced our range from earlier. So for every iteration of the for loop, instead of name being 0, 1, 2, 3, and 4, our name variable will update from John to Ava to Steve to Kelvin. And we can see that this will print exactly that. This is also a very common use for loops. Do something once for each item in a collection. In this case, the collection of items is a list of names. Let's go over some more simple loop patterns. Say we wanted to approach counting, summing, and finding in a collection of values. The structure is fundamentally the same every time. First, we initialize before the loop, update inside the loop, and then use the result after the loop. For counting, we could do something like this. Numbers is equal to a list of 2, 7, 4, 9, 10, and 3. And for our for loop, we'll look something like, oops, and we'll have a count variable initialized to 0, and then we can do something like for n in numbers. Could even do something like for number in numbers, but we'll stick with n. If n is greater than 5, oops, we can increment count by 1. And then we can print count. What this is doing here is counting how many numbers are greater than 5. Count only changes when the condition is true. If the condition is false, count stays the same. In this scenario right here, we'll have 1, 2, and 3. So we should get a count of 3. See, that's exactly what we get. What if we wanted to sum the values in the list? Again, very simple. 2, 7, 4, 9, and say we wanted to find the sum of those numbers. And then we can have total is equal to 0, and then for n in numbers. Total is equal to total plus n. Since we start at 0, it's going to do 0 plus 2, and then 2 plus 7, and then 9 plus 4, and then 13 plus 9, which gives us 22. See, that's exactly what we get. Now, what if we wanted to find the first match in a collection of values? Say we had a numbers list that had 2, 7, 4, 9, 10, and 3. And say we wanted to find the first occurrence where n is greater than 8. Now say if n is greater than 8, we want to return the number that our loop has found to be greater than 8. We can set that at n, and then we can break out of this loop since we only need 1. In this example, right, we would go through 2, 7, 4, and 9. 9 is the first occurrence of a number greater than 8. So we simply set found is equal to 9, and then we break out of the loop, and then we print found. We ignore everything else afterwards, even though 10 is still greater than 8. And we see that that's exactly what we get. That's it for the lectures in lesson 4. As always, we're going to check our Git status. I've added a intro.py. We can ignore that. We can also ignore this. We'll add git add lesson 4, since that's all we want to contribute to the course repository. Write a git commit message, lecture 4 loops. Oops. And then we can push. And this will be saved in our course repository. That's loops at a beginner level. You now understand what the range function does, how for loops repeat code, how loop variables work, how to combine loops with the conditional logic that we covered last episode, how break and continue affect loop flow, how while loops repeat based on a condition you control, and the 3 most common loop patterns, counting, summing, and finding. In the next episode, we'll formally cover the lists. You've seen them briefly here, but next time, we'll slow down and explain what lists are, how indexing works, and how to work with them confidently. Thanks for watching, and I'll see you guys in the next episode.